Okay, thank you for your Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Chico Hermanu and Apribowo. I would like to present about my research with detailed impact of the birthday storage system on operation cost for reduced loss of load and containment. First introduction. The reason about the ascertain to the uncertainty of penetration renewable energy in power system with high amount of uh, high penetration in renewable energy causes such as reverse power flow, voltage fluctuation, frequency harmonic fluctuation, and other when the characteristic output renewable energy system, especially for power PV photovoltaics and wind turbine power plant, is high intermittent, high uncertainty. So it can be to make a disturbance for stability in grid power system. So the electric power system need to be flexible to use increase amount of reliability connected. So one observation is using the BESS or battery energy system is when our overcome the stability of the power system. BESS can improve the performance of electric power system. Can limit the price of the curtailment of PV and reduce loss of load. The integration BESS can have potential and lowering the greenhouse, so lowering the cost estimation and lowering the production of JOX. So with amount of the height of interest in electric vehicle, we can grid advantage. One of the grid advantage is you using the second F battery or return battery. Return battery or second battery is a battery with state of heart amount 80%, 80% or 60 until 80%. So you can return battery can still be used to increase the resistance capacity of renewable energy system. The solution, one of solution you can be as changing is applying the optimal sizing and setting PSS input system with a grid scale. The research is using pressure return battery as PS power system will compared again and lowering the operation cost. The challenging in our research is how to modeling about the operating PSSs and invested using and setting and sizing in grid scale power system. And the optimizing PSSs will get best optimal result in sizing and setting with scenario in grid scale. The strategy to determine optimal grid capacity will depend on energy capacity and power rating. So the technical stability objective from investor point of view and or utility point of view. You can see the objective function in our research. In equation one is about the total operation cost on all total planning cost and one day scheduling. The causes of operation cost variable variable uh, independent about the empirical independent about operation cost, dependent performance cost, value of loss load, and installation operation cost. Equation 2 about fuel cost, equation 3 about the PV curtailment, equation 4 about loss of load, and equation 5 about the investigation of battery energy system. The equality design constraint about the power energy balance, the active power flow, active power limitation, the limit for load shedding power. The proper balance about inequality DG operation constraint. RAM rate constraint about the PV operation containment constraint is consists of the limit of the power of PV output and PV containment power. And also we use in equation PS operation. You can see that in equation question about pattern just and just is a key point use of PSSS as rating limit are just and just. The balances our PSNG capacities also. The proposed method about using data parameter about uh, beginning the data parameter, profile duration, profile PV, input the profile battery, input the profile demand, and input profile cost. We now solve the total present cost is conducted the mixed interlinear programming and method the branch and board. Minimal total operation cost we use a power and energy battery into the system. Use technology uh, about the press and return battery, solve the daily operation cost about power aggregation loss, power flow, voltage angel, power voltage, power charging, charging, and EPS continue. With the minimum operation cost, we know the total operation cost all of us is trying. You we know we cannot find the optimal uh, placement or setting and sizing of PHSS with optimal solution. So optimal solution we can know about the bus and technology, battery, energy and power battery. In case study in our research, I use IEEE 24 test bus system modifier with a PV scheduling with 1 day scheduling or 24 hour. The demand load is 24 hour. Table of one and data parameter PSSS, new battery and return battery cost, round trip efficiency, daily service discharge, power rating cost, operating cost, installation cost, and maintenance cost. And study to analyze the effect of PSS using a comparison of press and return battery on the cost of the population. We analyze 5 cases. Case A, daily operation cost without PSS. Case B, operation PSS press battery without optimization PSS. Case C, of daily operation PSS with return battery without the optimization of PSS. Case D, using the press battery using optimization of PSS sizing and setting. Case E, daily operational system with return battery or secondary battery life using optimization sizing and setting battery. In case A, daily operation power system without PSS, we know the total operation cost with high total operation cost are highly affected by unsupervised engineering up to 8 million 2500 dollar. So this happened because the energy supply is cost high. The loss of demand is high. Loss of load and demand and portable payment is production from demand is high, cannot be stored in battery. And next the case B, we now using a fresh battery with fixed battery size and setting. We now use you can see that the only dispatch battery charging and discharging in 1 day scheduling is 3 times charging. This time charging it can be using power rating 80 megawatt, 80 megawatt, energy rating 100 megawatt hour. And using a bus 19 bus. Basis can reach the loss of local property cost property self and using base can reach the PV curtailment causes 75.35% from B and then case A. And case J with a return battery with fixed size and set. We know we find that PV curtailment cost more than lower about the 75.55% from case A can reduce operating cost more lower than case B. For 40.70% case B with total daily operation cost more lower than case B. In daily operation case D, press battery optimization with optimization basis with a number of PSS. We know that you can see power rating more effectively in past 5, past 7, past 8, past 30, past 60, past 90, past 20, and past 5. We can now we reduce cost more lower than cash pay, and because the optimization BSS with setting and setting are more efficient, more lower than before. And the last case E is daily operation use return battery optimization setting and setting BSS. We know the reduce cost more effective cache G. We know 30.63% before from a cache G. Comparative study, we can conclude that uh, cache G is more effective using the only three BSS with a total capacity and total energy more effective and more operation cost using return battery cost. Using return battery model is cost by 38.94% PS without optimization. So more effective and more efficient before without battery PSSS. And the conclusion in this balancing of PSS can set and set the grid system can reduce the energy cost and not supply vehicle time to reduce the total operation and improve system reliability. Based on result, compare the method of the PSS, the total daily operation cost are higher. Due to the cost average of total supply cost PV curtailment etc. The PV curtailment cost 75.35 power lower than grid without PSSS, so more effective, so more efficient before without PS on without the optimization setting and setting PSS using. Future research we can more research proposition so we figure long-term model, not only one day scheduling. And the important of battery degradation to in considering the model of battery optimization can use the model battery energy storage optimization is 10 years horizon or 20 years horizon. Okay, that's my reference. It is an end of my presentation. Thank you and attention. Uh, Thank you very much.